Okay, so welcome to the Multisim Workshop, the ECE 271 version. And what we're going to try and do today is try and solve this circuit for a few parameters. Okay, so for this specific assignment, we were told to consider a problem from a textbook and basically solve for the voltage using diodes. Now, whenever solving for diodes, typically we have to start with a certain assumption after labeling, if I remember correctly. So for this, for this circuit, so you have two voltages, a resistor, and two diodes. One thing to note about this circuit is the direction that the diodes are facing. So you have one diode that's facing in the direction of a positive voltage and another that's facing in the negative direction of said positive voltage. So when you label, you're typically going to label like this. Then for your diode, you would label accordingly. And for your resistor, you would label like this. Label like this. Now, the voltage for the diode that we're supposed to use, or the voltage constant, which is V on in this case, was given to us as 0.4. Now, in that, inside, before you start trying to solve for it in Multisim, what you should do is try and solve for it analytically. So analytically, what you end up getting is a voltage diode 1 of 0.4 using KVLs and KCLs. So if you position your KVL correctly, you have a KVL going this way because that voltage is attracted to ground. So you have for your KVL A, you have a voltage of 9 plus a current times 22 kiloohms times a voltage in diode 2, or plus a voltage in diode 2 plus a voltage in diode 1. So when you go through these, typically you start with assumptions for which diode is on and which diode is off. So I'm going to first start with the assumption that both diodes are off, because when both diodes are considered off, I'm going to start with the assumption that this diode is considered on and that diode is considered on, because the way that the voltage is reflected, this is the higher value voltage. So the polarity of the circuit would be going in this direction, which means that this diode will capture all the current coming through. And this diode, since it's facing in a negative, in the opposite direction, nothing is going to go through. So we assume that diode 1 is on and diode 2 is off. And in that case, your diode 1 would have a voltage of this voltage constant V on. If you wanted to use that KVL, you could use that. And the voltage diode 2 wouldn't have a voltage since no current is going through. That would not be there. So then, if you were to still follow this KVL, you would have
A quick question: why is a V on 0.4? Did you set that?
Yeah, it was a given value as 0.4.
Okay,
Typically, cool. With these kinds of problems, you'll be given that value, or will you have to find it? I don't think you'll have to find it. Typically, it's given to you.
Sometimes I think you do have to find it. Actually, I took this class over the summer, and some problems gave us setting VRMS, and we had to go from there.
That's true. I forgot I took this class in the spring. But anyway, you got so if you're still going to follow that KVL, this voltage wouldn't exist, so you would just have that 0.4 equals 0. So since the KVL goes that way and you're trying to find this current value, you add like this. Your diode current equals 9 minus 0.4 over 22 times 10 to the third. And that would give you a current value of 'I hope I did that right. I don't think I did that right. Okay, there. You would get
Thanks
a
for doing
current.
this, by the way.
Oh yeah, no problem. You would get a current value of 0.39 milliamps. Do this correctly. Oh, I did a different KVL here. So, oh, whoops. Oops, I went about this incorrectly. So I started with the wrong KVL. That's why it's imperative. I hate to sound like Levkov, but it's imperative that you label correctly. So instead of starting with that KVL, I'm going to use this one over here. Now, the reason why I'm using that one instead of this one, I also forgot that in my assumption, I assumed that the second diode was off. So any current that you thought that I thought was going through this diode isn't actually going through it at all. Since this thing, the negative side of the diode is right there. So my actual KVL would be, it'd start from the top and go to ground. So you have that 6 plus the diode current times 43 times 10 to the third plus, no, not that, plus 0.4, which is V on. Then you find this value, which equals 130 microamps. No, I forgot to put that. And then once you get that, then you have to check to make sure that the diode current, like the V on constant, will equal your given value, which was 0.4. So using the original diode equation, you get that. Now that you have that, going into Multisim, you would basically check for each of the things. So to start with, like, the actual setup of the circuit, let me make a new window. So you have your tools of power sources, diodes, and you're always going to have to remember to take a ground source, because if you don't take the ground source, then your circuit won't function. It'll essentially come up as an error. Now, if I remember correctly, the first voltage that we used was a voltage of 6. And you set it by just going into the properties and set. Is this understandable, by the way?
Yeah, totally.
Okay, cool. So
This is helping out a lot. I didn't pass this class over the summer, and well, I chose to actually just I studied the rest of the class. My grade was too low to kind of pull it up, but the labs I was always doing bad on these labs because of like little mistakes. So this is helping out a lot.
okay, that's good then. So
It's mainly like just the power sources, and sometimes I don't really know how to properly. I guess some power sources require you to specify which current, where, and sometimes it doesn't really work.
that's very true. That sounds like AC sources if I think about it. So then you have your basics, which will give you all like the resistors you need. For this one specifically, we needed a 22K. Oh, in order to rotate, just press Control R.
Oh, sweet. Is that Command R on the Mac? Actually, I'm using Windows. Never mind.
Okay. But it probably would be Command R on the Mac.
Yeah, actually, I had to download on the Windows computer because the Mac only has the browser integrated version.
Mm-hmm. And then you also needed a 43K resistor. And then same deal, Control R. Now, for diodes, it was instructed that you use a virtual diode. And we had 2 diodes, if I can remember correctly. You had one facing this way and another facing that way. And then we had another voltage. And that voltage was negative 9.0 volts. Okay. So you have everything, you have all of your components. Now to wire up, you would just go to the tip of whichever component and extend it to the other end of the component that you need. Also, do you see the numbers that are appearing on some of the wiring?
Yes, I did.
Those numbers are nodes. They basically detail where the current is coming from. So, in order to turn that on, you would go to Tools and
It's actually I think it's in Options, I believe, right?
Options, Sheet Properties, Sheets, and I think it was.
It's actually the Show All Nets.
Yeah, the net names. The net names, and you would turn the show off. Since I have it set already, it does it automatically. Now, You have to measure and make sure the current you have going through each of the diodes is correct. And in order to do that, you have to get probes. Window. But in order to get probes, you have to, these are your sets of probes here. So you have a voltage probe, which will display voltage, a current probe, which will display current. You can also use this probe, which will display the difference in voltage between 2 points in a circuit. So if I were to put one here and here, it would use this probe as a reference to measure the difference in voltage. No, I don't think.
Are you able to measure resistance with anything other than the ohm meter? Like, can you use a probe and like make an equation or something for resistance?
I don't think you can measure resistance using a probe. In order to try and measure resistance, what you could do is have a voltage and current probe in around the same spot. And if you were to
And then
measure,
just do the division.
yeah, just do the equation E equals IR. So
Cool. That's what I did. Sweet.
okay. So in that case, I'm gonna put a voltage and current probe since they're just a bit more convenient to use. I'm gonna put one here, and in order to flip the probe, you got reverse probe direction. And I'm gonna put one right here. So I don't necessarily need those probes. And in order to change the probe setting so that it doesn't display everything like all the voltages in the world, just go to properties again, parameters, and customize your parameters so that it'll show the things that you need to show. So it would just be voltage and current. And you have to do it for all of these probes. Okay, so once you have that, you just adjust the circuit itself. Once you have everything in order, you can go ahead and start testing your circuits out for specific measurements. So as you can see, I'm getting a measurement of 126 microamps going down that way, and going down this way, I'm getting a measurement of 9.61 picoamps, which is essentially zero in this case, since you have a voltage facing the other direction. So the amount of current going through this part of the circuit is very minimal. Now, if we go to the other circuit that I had, in order to make sure that the diode voltages are correct, you would have to use that difference voltage, the difference voltage probe that I was talking about earlier. So I really wish that window could move. Come on. So that would be this thing here. You would put the positive end at the positive end of the diode and then put the negative end here. And you don't want your probes to get too cluttered up. So just make sure you flip them when needed. As you can see, the voltage given is 9.6 volts, but let me actually make that a little bigger. And in order to change font so that people can see your work a little better, you can just click that. Okay. So as you can see,
What was that you actually clicked for that?
for that, in order to increase the font size, it's just
Okay, yeah.
this size tab.
Cool.
So you got that, and basically what you would keep doing in this sense is keep measuring the diodes to make sure they equal that constant that you were given, which was 0.4, or like the voltage within the diode itself. And in order to do that, you have to change the parameters of the diode. So to change parameters of objects, you go into properties and you can edit whatever, you go to edit model, and you would basically have to edit whatever constant is needed. So in this example, what you would be editing is the saturation current. I don't necessarily want to tell you what it's edited to, but you would have to change this parameter in order to keep testing what voltage model or what voltage you could end up getting. So, and you would just keep testing until you get the right cue point for said for your said analytical solution, because when you analyzed it, you had the Vion of 0.4, but when you test it initially, there are some parameter differences here. So that's up to you to find if I'm making sense.
Yeah. How did you get the Q points? You did that analytically first?
I did it analytically first, and then I tested it within the within Multisim.
Multisim. Okay. So, and basically, you use the parameters of the voltage and the current, or you use the parameter of Vion?
I assumed the parameter of Vion because in these models, I think in these models, it's the saturation current that determines your Vion. So if I go to edit model, you see the saturation current. That's the default saturation current.
Okay.
And in order to
So I guess we're going to learn how to do the Q points probably this week then.
okay, yeah,
Because we just started diode work.
Okay, in that case,
Yeah.
then the okay. Okay. In
I
that
know
case,
I know some things from last semester.
okay. So in that case, I
And I do
might.
remember the saturation current. That's in the equations that you use
Uh,
to find those things.
yeah. The saturation
Okay.
current is in the equation. It was like, can you see my screen?
Yeah. Okay, I see it.
Yeah. So basically, the way that he's going to explain it, there's going to be a lot of exponents involved with diodes that um all of these equations it'll play a part too in the actual sim assignment.
Okay.
So what I might do is that I might try and host a little multi-sim help Discord session because I didn't realize that I was doing it so early.
Oh, it's all good. I just couldn't find the other or this room at first. There's a room.
Okay, yeah, I have to make sure that for next workshop I do that properly. So in that
Even if there's a multi-sim Discord, that would be cool too. Just to drop any questions, or if we could put like a screenshot in there, maybe just like get another pair of eyes on it.
I could do that just for this assignment though, because I didn't realize I was starting it, so I didn't realize I was gonna
Oh,
have
the
the
diodes.
yeah.
Yeah.
So
Okay.
basically, because this I recorded this meeting, so it'll be on the IEEE Discord as well as the ECE Discord for future reference.
Cool. Perfect.
Okay, so in that case, I think I'm done, and I'll have this up on the I'll have all of the recording up on the IEEE Discord and such. So, you have any other questions that I can answer?
No, not at this moment, really. I just kind of got to mess around with it myself. I got to start this simulation and see where it goes for me.
Okay, just yeah. I just hope like as far as like actually using multisim itself, I at least help with that.
Oh yeah, absolutely. Like, definitely didn't know you can flip a diode, flip things with the command, or flip the probes. That's actually really useful.
Hmm.
And just everything. Yeah, thank you. I really appreciate that. Another thing, um, do you do you kind of see where the current's going before you decide where to flip them, or can you flip them and figure it out as you do the simulation?
Well, let me just